All right, so today's project is ham radio adjacent. Not exactly we're going to do any radio today, but we are going to do a project that's going to enable us to do a lot of radio. So anyone who's read my QRZ page knows that my buddy Terry taught me the way of the desert brass pounder. And that's where we go out into the desert, set up wire antennas, and have all sorts of fun making great contacts all around the world in CW. And in order to do that, well, you gotta bring a little power with you. So we typically these days we're using lithium iron phosphate LiFePO batteries, and in the desert we charge them on solar. But you can't always charge on solar, and sometimes you want to get everything topped up before you get out there. So today I'm going to put together something to help us charge from mains power all the batteries. And what I've got here, this is actually the 12 volt converter from an RV. And RVs have pretty good 12 volt power systems. This is rated for about 50 amps. So that's going to be approximately 600 watts or so. And it'll put out 600 watts, whether that's being used by a device. So this can be a power supply, or whether that's charging a battery. And it's a pretty good battery charger, and it's a pretty good power supply. This particular one is actually for a lead acid battery. The reason I have this laying around is because I had replaced it with a slightly higher voltage version in one of my travel trailers for charging lithium iron phosphate batteries. But this will still charge, lithium iron phosphate batteries or lead acid batteries. So whatever we happen to be using, this will do the trick. It might not be quite as it may not completely top up the lithium iron phosphate batteries, but it should at least charge them. And we're going to test that. So we've got the converter. We've got this Harbor Freight ammo box that we're going to mount everything into. I've drawn some pictures on the sides where we're going to put everything in place. And we're also going to mount in here a Hall effect sensor. Hall effect sensor is pretty cool. So what this is going to do is this is actually going to go, the positive is actually going to pass through here, and it's going to be able to tell us how much current is being drawn. So Hall effect is, it can tell us our voltage and our current, so we can pretty much get an idea how much power is coming out of the converter at any given time. It's not great for testing the state of charge of batteries. For something like that, I would typically use a shunt type sensor, and I would connect that to the battery, not to the charger. But for this, you can see if it's putting out, full, 50, 40, 30, 20 amps, whatever, you can see that it's pushing a lot of power. And then if you're only charging a battery, when that drops down, when that starts dropping down to, 5 amps, 2 amps, 1 amp, then okay, we're fully charged. We can let this go at this point. So yeah, this is going to just mount right on the top of the box, and we should be in pretty good shape with that. So oh yeah, these are definitely way too big for the crimper. Let's get out the big crimper. And that's it right there. So this big crimper, what we'll do is we'll push the wire into there, and then I'm going to actually take this outside, but that mounts in there, and then we beat it with a hammer to crimp it down. So let me just get all this stuff prepped. Let's see, how long are those? They're about that long. These are the crimpers I got from Radio Shack when I was a teenager. I feel bad for the teenagers today who don't have a Radio Shack in their neighborhood to go to. But then again, I guess we all can just order from the internet now, which is awesome in and of itself. I'd like that to be just a little bit deeper. That will do just nicely. Now let's do the same thing on the positive side. That will also do just nicely. All right, I'm going to take these outside and give them a hit on the crimper, and we'll be right back. All right, we are back, and you can see the results. Those now have a nice stamp on each one of them, thanks to the head of the big crimper. All right, very cool. All right, so here we are. It's been a couple days. I was really unhappy with the silicone I put on here. I was really expecting it to do a little bit better job sealing, and it's just too squishy for this application. So shame on me. If I ever rebuild this one or build another one, I will definitely use a different kind of sealant, something that's a little stronger and a little harder. That being said, I did put 2 screws holding the top of this on just so that it's nice and stable. I went ahead and I disconnected the positive wire from the Anderson connector so that I could put this Hall sensor, this Hall effect sensor around it. So that's just tucked in down there. I did cut a hole in the side here, and on the side you can see I've got a little indicator, and this is what that Hall sensor is connecting to. And I also added a little flap on the front and back just so that it could have some airflow going through. This converter does have a fan that runs if it detects it gets over temperature. So I've just got one little solder point left to do here. Nothing fancy. And then everything should go live. So it's already got kind of a glob of solder on there. So let me just clean that up a touch. All right, that's not the best soldering I've ever done in the world, but shame on me again. I didn't plan that before I put everything down in there and had to reach kind of a funny angle with the soldering iron. But that being said, we're ready to close this up. And we've now got our little readout on the side. So 13.8 volts. And of course, no amps going through there. All right, so here we are at the steps, and this is a fifth wheel. So under the steps, I've got quite a bit of space here. And under there, I have a 300 amp hour, 12 volt lithium iron phosphate battery. In the back corner here on the left, this is the display from the solar charge controller, which of course it is nighttime. There's absolutely no solar right now. It's showing 13.3 volts. And then on the right, the green screen here, that is the battery state of charge monitor. So that can detect the amount of power going in or out of the battery. And it does a pretty good job of keeping track of the battery's actual state of charge. That being said, this battery has not been charged from a converter for several years. It's only been charged exclusively by solar. So that might be a little off. And when we plug this in, it might continue to charge even after it says it's at a 100%. So we'll see what that does. I'm also interested to see if the display from the Hall sensor is pretty close to the battery state of charge sensor, which will also tell us, how quickly things are charging. One thing I am going to do, if you can see on the little green screen here, it shows that I've got an 8 or 10 watt draw right now. That's because it's got this has an always on 3000 watt pure sine inverter, which is going to an automatic changeover going into this fifth wheel's power panel. So if we get disconnected from shore power within 1 hertz, it swaps over to the inverter. So I'm going to turn that off just to remove the draw. So now our draw is showing 0 watts, and that'll do a pretty good job of showing us what we're actually picking up through here. And I think I've got enough to actually bring this right up here. Awesome. Okay, so this again is a 50 amp RV converter that's in this box. And it is not designed for lithium iron phosphate. It's designed for sealed lead acid or AGM batteries. That being the case, it's not, it can still charge a lithium iron phosphate. It's just not going to do as good of a job as a charger that's designed for the LiFePO, because the voltage is slightly lower. I think it's about maybe 0.2 volts lower. So we can see that our voltage readout on the, on this box that I built is shown 13.7 volts, and it's showing that it's putting out just about 22 amps. That's pretty close, 21.7. On the battery state of charge monitor, it's showing that we are, we're taking in, we're saying 21.7 or so at the same time that this one said that. So they're pretty close. They're about a 1 amp difference. And the 6 gauge cable right here, the 6 gauge cable is about, how long is that? It's about 1 meter long. So over 1 meter, if it's losing, somewhere, looks like it's somewhere between half an amp and 1 amp difference between these two. Could just be differences in the meters. Could be differences in position. This one is at the battery, this one is at the converter, or it could be just a little bit of loss in that cable. It's definitely not the greatest quality wire in the world. You can also see that at the output of this converter is showing 13.7 volts. On the battery side, the battery showing its state of charge is 13.5 volts. That also checks out. As the battery becomes fully charged, I would expect these to even out and get pretty close together. So we'll see what that does. But we're pretty close to fully charged. This was only down about 10%. Not 10%. It was only down about 10 amps, according to the state of charge monitor. And we could see that the amperage on both meters is dropping. We were up around almost 22 amps when we started this, and now we're down to 18. It's just going to keep going down and down and down. That battery's only going to take as much power as it can take until it's fully topped up. Or in this case, because it's not actually, this converter is not actually designed for lithium iron phosphate, it's going to take as much power as it can until the output voltage matches the battery voltage, which at 13.7, that's going to be a little lower than fully charged. This converter does have a built-in timer, and it can cycle up to 14.4 volts. I think I would need to unplug it for a while, and I don't know how long exactly, maybe 10 minutes or something like that. I'd have to go read the manual to find out for sure and plug it back in. And it should go into, for lead acid batteries, what's designed as the bulk charge mode, and stay at 14.4 volts for maybe 4 hours or something like that. Again, I have to read the manual on this and see if I'm remembering those specifications correctly. But either way, I'm very happy to have a way to charge this particular battery system when the sun's not out, especially with a cross-country trip coming up. The last time we went cross-country, it rained every day. It rained everywhere from New Mexico through Texas, Kansas, up into, where did we go up into there? We went up into Illinois, and it didn't stop raining until we got up into the Northeast, up into Vermont and upstate New York. And with all that rain and all that cloud cover, we basically didn't have any solar charging at all. So I rigged up something. I was able to charge about 5 amps into the battery. And that was not enough, but we got through it. And now if we ever get in that situation again, we can pull over somewhere with power. And if I'm able to put out 20 or 30 amps from this device, we should be able to charge that battery up in just a few hours time, or at least get it topped up to where we're pretty comfortable again. All right, well, the charging cycle's done. Overall, everything went great, except when I went to pull the Anderson connector out, well, that silicon that I wasn't happy with proved why we weren't happy with it. So we're just going to clean that up. Oh, looks like the razor blade's going to be the right tool for that. So overall, this experiment went pretty well. What did this cost me? So the Anderson connectors, I think I bought those for $12, maybe $15. The ammo box from Harbor Freight, I think I got that for $5 with a coupon. Everything else I had laying around in the parts box or the junk drawer. And for $20 and some spare parts, I was able to build a 50 amp charger and or power supply. And remember, this will do a great job as a power supply. I could hook up my entire station out in the middle of nowhere with a little briefcase generator, or this could charge any of my lithium iron phosphate, sealed lead acid, or AGF batteries that I happen to need to go out in the field with, or go on a road trip with. So I'm happy with it, and I think I'll get years of service out of it. If I ever rebuild this, I've got a lot of lessons learned. I can do a much better job, and I'm definitely not going to use that silicone again because that was just gross. Anyway, that's it for now. I'm going to go have fun, and until next time, 7-3 da 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 da, and I hope to talk to you very soon.